Hello everyone, welcome back to our online tutorial. Today we have a beautiful question on trigonometry. Trust you me, it is quite very educative. Now we have sine of theta equal to n minus n divided by n plus n, and we are to evaluate 1 plus tan square theta. The best approach to solving this problem is using trig ratio. Now, from our basis in geometry, we know that sine is opposite over hypotenuse. So I will draw a right triangle. I'll fix the angle here, theta. Now from what I said, this acronym is very powerful. So it helps to define the three basic trig ratios. The so you see here means sine equal to opposite over hypotenuse. The car here means cosine equals adjacent over hypotenuse. The total implies tangent equals opposite over adjacent. Now with this, we should be able to fix this guy into this triangle. We are given sine theta equal to n minus n divided by n plus n. And we know that sine theta is opposite over hypotenuse. So this is the opposite, n minus n, and this is the hypotenuse, n plus n. So you can see that this triangle, there's a missing side, which is this adjacent side. So using Pythagoras' theorem, theorem, so the value of s becomes n plus n all squared minus n minus n all squared. As you can see, what we have here is a difference of two squares. And a difference of two squares, we are already used to the formula. So if we have a square minus b square, this becomes a plus b, under parenthesis a minus b. So this will make our work faster. So a is n plus n, b is m minus n. So with this, s square will be n plus n plus n minus n in one parenthesis, n plus n minus n minus n in another parenthesis. So at the end of the day, n plus m is 2m. So we are going to have 2m, n minus n is 0. But if we come here, m minus n, if we open this inner bracket, so m will disappear. N minus n will give us 2n. So s squared is going to be 4mn. Now, if we take the square root of both sides, the value of s is going to be the square root of 4mn. This implies that I should take the square root of 4, multiply the square root of mn. Now 4 is a perfect square, so the square root is going to give us 2. mn is not a perfect square, the square root will be a surd. So s at the end of the day is 2 root mn. So with this, we are home and dry. So from this triangle, we can begin to define other trig ratios. So I will give some seconds for you to screenshot what we have here. Now, our aim and objective is to evaluate 1 plus tan square theta. Now, from this same right triangle, as you can see, Tan theta, like I defined at the beginning, is opposite over adjacent. That is m minus n all over 2 root mn. Now, 1 plus tan square theta, that's our objective. So that becomes 1 plus m minus n over 2 root mn all squared. That's what 1 plus tan square theta will give us. So if we expand the expression, all we have to do is a simple algebraic work. So I'll write 1 plus, if I'm to expand this, this is m squared, n times minus n, minus mn, minus m multiplied by n, another minus mn, then minus n squared. That gives n squared. All divided by 2 squared is 4. Square root of mn squared. The square root will disappear, you have mn. So as you can see, this is an algebraic fraction. So no need to be taking LCM at this level. All we do is to use the butterfly method. So 4mn times 1, that will be 4mn. 1 multiplied by this entire numerator, it will remain the same. Everything divided by 1 multiplied 4mn. That will be 4mn. So at the end of the day, if we collect like term, you can see 4mn minus 2mn. So that's going to give us plus 2mn. So I can write the final answer to be m squared plus 2mn plus n squared divided by 4mn. So this is the final answer for the problem. As you can see, systematically, it's a very simple problem. So thanks for watching. Please continue to support us by liking, sharing, commenting on our videos. See you next time. God bless.